All right. Well, welcome, class. I know that you all are ready for this lesson. It's going to be smooth. This is 222, 223. Okay. This is the last lesson that we have, or the last section in this lesson. Here's the deal. The main thing I want to show you here is the domain is talking about what x values are involved. What x values are involved. Now, if we just have a parabola, a quadratic here, just kind of in space, I just draw it on a coordinate grid like we have been, then this keeps going over to the left, or comes up from the left, right? Where does it come from? It comes from negative infinity all the way up. Or if it was one of these, in fact, that might be one way to kind of elaborate. You don't have to change it. It's going to be the same answer because all parabolas that you're dealing with either face up or face down. The x values involved, it keeps going over to the right and over to the left and over to the right forever. So if you just have a parabola in space on a coordinate grid, it is always negative infinity to infinity. It's different for scenarios. In scenarios, you have to kind of reason, right? So if you were in your Mario Kart and you threw a banana at an opponent, right? Right? You want to throw it up there. You don't want to throw it behind you. The one opponent's in first, right by the finish line. You want to hit him with that so you can pass it and get first. And get more rubies. So you can only throw it forward. So what is the actual domain for this one? If I want to throw it at that person, am I going to throw it behind me? No. So the domain for this one is going to be from 0 to what? 75.5. Okay. Before this morning, I had like a shot put example, right? And I think, in fact, shot put might be helpful in this to see it. So you're a giant person now. If you're doing a shot put, you throw it forward, right? You never throw it backwards. It probably would hurt you to throw it backwards, right? Okay, so you throw it forward. So if this was shot put or banana throw, or you're throwing something, it's from 0. That's the first x value that is involved with this graph. In this case, it doesn't go down through the ground as our kind of more hypothetical parabolas do, our perfect scenario parabolas. So banana throw, we'd have a domain of 0 to 77 or 75.5. How about this one with the half pipe? We start up here, we're at 0 for x. We're going to proceed over to what value? 50. So if the half pipe is 50 meters long, then my domain would be what? 0 to 50. Okay. It does depend on how they designed the problem. If the person had designed the problem where this was my y-axis, right in the middle, then I would say it would have to be from negative 25 to positive 25 if it's the same distance for the half pipe. Okay. So just look really close on where, if they give you a graph, you got to relate the domain to the graph and what information they're giving you. Okay. What we did yesterday as far as if it's increasing or decreasing, if you weren't totally sure about that, today might help you out. Because the average rate of change is really our slope, and the average rate of change we'll call the AROC, our slope. All it's asking is going from x is equal to a to x is equal to b, what is my slope? So all we're going to do is we're going to be given 2 points on the parabola, right? And we are going to just find the slope from that. It might help you. You might remember this from Math 1, where we said, well, that's x sub 1, that's y sub 1. That's x sub 2, that's y sub 2. And then you would just do, okay, slope is really the change in y over the change in x. And that still works for this. It's the same thing. We're not changing anything. It just happens to be that the 2 points are going to denote the average rate of change between those values. So between negative 1 and 1, what's going on with my slope? Those two values equate to these points on the function. So I would then be assessing those two functions. How far up do we go? How far up do we go to go from to go from 2 to 7? We go up 5. How far over do we go? From negative 1 to 2. 2. So that matches our AROC. You could even do it that simply. we're looking at the slope between 2 points on our parabola. And if it's positive, it's increasing, you're going uphill. If it's negative, you're decreasing, you're going downhill. Okay. So pretty straightforward. We could have inputted it here into our equation. F sub b, so that's looking at our b group. And essentially what this is saying is, I'll put it in here for those that like this notation, y sub 2 minus y sub 1, x sub 2 minus x sub 1. The change in the y over the change in the x. The rise, positive or negative. The run, positive or negative. It's just slope between 2 points on the function. Okay. So let's look and see what we did. We put in y sub 2, 7, minus y sub 1, 2. Then we put in x sub 2, boom, minus x sub 1. I had to put the parentheses there to make sure I don't lose that information. This lesson's going pretty good, I think. Yeah? Yeah, look at this. All right, let's keep going. Maybe I'll even teach you the derivative, which is a shortcut. Wait a minute. No way I'm doing that. My record today is, I'm batting 200 today. All right, let's see. Let's look at this scenario. First off, if I go between these 2 points, can you tell me if I'm trying finding the average rate of change between these 2 points? I'm really looking to see what my rise over run is between those points. Essentially, that line denotes that. Is this decreasing or increasing? Decreasing. So my slope for this, my average rate of change, AROC, should be negative. Okay, let's see if it is. We'll call this, you know what, I like this. Tn, I'm going to keep it with this for today. X sub 1, y sub 1, x sub 2, y sub 2. Those aren't exponents, it's just saying which is the x, which is the y. We have 2 of each, so we have to denote it or we get confused. So I look here, I have my two values. So I'm going to go ahead and say AROC. The change in y's, so y sub 2 minus y sub 1, over the change in x's. So let's put it in 2 minus 7, 1 minus negative 5. So these are just what goes on the top and bottom, if that's helpful to write it that way. I think so. AROC equals, let's see, negative 5 over 6. Can't reduce that. We're done. Does that match? It's decreasing. We're pretty good. Yes?
It also doesn't matter if you like sub 1 versus sub 2 versus 1 0.
Yeah. Why don't we try that to prove it? Let's try to prove it. So if I look here and I'm just, what Tn is saying is, this can be y sub 1 minus y sub 2 as long as this is x sub 2, x sub 1 minus x sub 2. Let's see. You can change basically what we're doing. We can go y sub 1 minus y sub 2, x sub 1 minus x sub 2. It will work out the same. 7 minus 2, negative 5 minus 1. What do we get? We get 5. We get negative 6. It's the same. You see? So as long as you're consistent, yes, it doesn't matter. It's foolproof. Which goes first? That's it. That's pretty good. Questions? Homework. Homework is 1 through 7 in the workbook for this section, 1 through 7 in the workbook for this section. So you got 14 problems. It's on these topics. I think that I'm going to try one more time for what I was messing with you on the board before. I'm going to give one more example, and I have a better, I just thought of a different, more smooth way to do it. Who wants to know the derivative real quick? You do. All right. Awesome. Right? That's our function. If we found the derivative, we'd call it f prime. F sub prime of x. You could call it dy, d over d, dy. There's a bunch of ways to show it. dy or y prime. Take the exponent, bring it down, and subtract the exponent. 2x to the first. The derivative is a process. Here, this is to the first. Bring it down and multiply. subtract out one of the exponents. So it's x to the 0. What's that? This is x to the 0. Bring down the 0. 0. Now, if you wanted to know the slope at 2 for x, you plug in f prime of 2. It equals 2. That's our A-rock for that. You take the derivative, you find the instantaneous slope at any point, which isn't something you could do now because we have 2 points to find slope. You could then, really what it's like, moving closer, 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 closer. Derivative is just right at it. It's crazy.